Here is an explanation for final exam question number 8, the answer to this one, on page 662 of Teach Yourself Electricity and Electronics, 5th edition. That's edition number 5. The questions so far in this exam have been relatively easy. This one is a little bit more difficult. It asks us about a component that happens to have a negative imaginary reactance whose coefficient is twice the resistance. So, for example, if we have a resistance of X, then we have minus J2X for the reactance. This could be 100, then that would be minus J200. This could be 500, then that would be minus J1000. The actual values don't matter, it's the proportion or the ratio of the values that matter. If we draw the lower right-hand part of a complex impedance half plane like this, and we say that the increments are the same size along the axes, so that, say, 100 ohms on this axis might represent an inch, then J100 would represent an inch going that way, so the axes have the same sized increments. That is called a Cartesian coordinate system, after René Descartes. You probably learned that in pre-calculus courses or advanced geometry, but in any case, in this coordinate system, you'll get a vector that points in a certain direction that depends on this ratio. Whatever this ratio, whatever these actual values are, the rectangle is twice as tall as it is wide. That means that this vector subtends an angle greater than 45 degrees relative to the r-axis, but less than 90 degrees, which would be pointing straight down. This phase angle, which we generally symbolize as a Greek letter phi or phi, which looks like an O with a vertical line through it, it's a negative phase angle because we're going down in negative directions. So this angle phi is greater than minus 90 degrees, which would be going straight down, but it's less than minus 45 degrees, which would be going out equidistant from the two axes like that. So this phase angle is between minus 90 degrees and minus 45 degrees, and that is choice D, as in delta. It's hard, but not impossible.